All right, guys, ready to get started? So this one is on weather and sailing, and I want you to stop me at any time with questions or to elaborate on certain things, because I'm going to kind of do a general overview without taking too long.
Sciencey?
Very sciencey. All right, things you want to learn tonight. Wind can be predicted using clouds if you know what to look for, and if you know where you are relative to them. All the powerful forecast models on the internet all process data given out by the government. So basically when you pick a weather site, they're just using different equations. So no weather site's better than the others. It's what works best for you. And I'll show you my favorites. The effect of high and low pressure systems, and how to identify dangerous situations if you're sailing. So the environment. Here's an overlay of our current weather, which helps solidify that more. There's the low, highs, yeah. So, one of the things that I've said a lot sailing, on big boats especially, is wind shear. And Ryan knows it's kind of an inside joke because like it's actually kind of a big deal, and they always say it's not. But basically, how this rolls into, if you ever look up, sometimes you'll see, if you look up right now, the clouds are going that direction. But the wind you feel on your face is really coming from right here. So if the wind really high up is going that way, and the wind you feel on your face is going this way, chances are the wind is going to shift to what the clouds above you are doing. Because it all plays into the fact that if you have water right here, the wind's going to be slower on the water surface, and it's just going to keep increasing as you go higher up. So this is a side view. Now, if you're looking from the water, let's say right here is your arrow of the wind you feel on the water. It's this little arrow right here. Now, 20,000 feet up, the wind's going right here. And you see this with the clouds. Chances are, I'd say all day I'm going to go to the left side because the wind is going to shift right, or vice versa. So if you look up and you see clouds moving in a different direction, you can usually bank that these two arrows are going to match up. And that's this little arrow and this big arrow, there and there. One of the other big sayings that I've always heard sailing is sail towards the storm. And that's what we're going to get into next. A real goal between all this is to, right now everyone knows how to see a puff on the water. You want to know how to see clouds 4 miles away and know a wind shift's coming, stuff like that. So it's kind of taking it to the next level. Now the next thing, and we're going to get into clouds next. Actually, I'll wait for it. So here's the different types. This is a giant thunderstorm, and this is just a normal rain cloud, no lightning. Huge differences between the two. Those go up 14,000 feet. These are only a couple thousand above, and they really die up fast. Now, if we're talking in terms of wind, I think you can guess. Thunderstorm is going to be really windy. Side note, the cirrus clouds you see on top, cirrostratus, those are like remnants of a bad storm. So if you ever have a really bad storm, you'll look up, you'll see the wispy clouds in the sky. Remnants of a bad storm. All right. So the real trick is to know where to sail around clouds. So let's say you're racing in Annapolis and you see a bunch of low-level clouds along the shoreline and it's totally clear skies on the other side. And let's say it's a long course, maybe not college sailing. Now typically what I'm going to show and prove to you is you want to go near those clouds because wind, clouds are literally the way to tell. A couple years ago, Bayview Yacht Club Junior Sailing hired Anna Tunnicliffe for a day, or maybe she donated her time or whatever, but she was a gold medalist in lasers, and she would literally look at clouds and be like, all right, wind's gonna shift in a half hour, it's gonna shift 10 degrees, go to the right side. And we're like, yeah, bullshit. And literally every single time it happens. So I'm not on that level, but you can always learn more. Yeah, the Volvo Ocean Race sailors, that's how they win races. They have navigators who identify this kind of stuff. All right. So there's two types of clouds. Well, a couple, but I'll show you what I mean. So you have clouds. Here's a cloud, you're looking down on it. This is a cloud that if here's the ground, you would see it decently high up, but puffy, not really tall. It's kind of in a building phase, you'd call it, because it's not raining, is the point. Now, in a cloud that's building, wind on all directions goes towards it. So, but once you get in the middle of it, all the wind is going straight out of the board. So if you sail directly under a cloud, and let's say there's no surface air, it'll be dead here, there'll be wind along all the edges, and yeah, you can bank on that. So now let's say you have a cloud where top view, and it's raining. Now, part of the air circulation in clouds is when it rains, how I imagine it is you can picture the air getting pushed out of the way with the rain. So if here's a top view of a cloud and outflow, wind is going outside of it. Thank you. Good. Glad you're paying attention. Okay, so differences here. Now, it gets complicated because now let's say you have a cloud with, let's say this cloud is an outflow, and there's a wind going this direction. Let's say the maximum wind coming out of this cloud is 10, and let's say you have a 10-mile-an-hour wind right here. So who wants to guess what's going to happen to the wind right here? Guesses?
0.
Chris is right. Cancel. So if you're on this side of the cloud and it's raining and the wind is blowing you towards the cloud, I'd get the hell away from that cloud. I wouldn't go to the edge. Now, if... Say again?
Is that with vectors?
It's science. So let's...
Change the battery on it. Yeah, make sure to edit.
I showed you a cloud and outflow. And what we found out was that all the wind comes out of it. So who wants to guess what's going to happen if you're right here? Where's the wind going to be coming from if you're right here?
Right in diagonal.
Add the vectors. The wind will actually be coming like that. So 0 right here, and as you get further away from the cloud, I mean, you can think about this later, but once you get to this side of the cloud that's an outflow, if you have 10 here, 10 coming out, you're going to end up with 20-mile-an-hour winds right here. So how I would picture this is, let's say you're sailing right here. And this is a real-world application of this. Let's say you're sailing right here, and 2 miles ahead you see a cloud, it's raining, and the wind's coming from right here. Your best plan of action would be to sail over to there, get your max wind possible, rather than get away from the cloud. Same thing applies with the rain cloud like this. So these are just typical rain cloud. If you got wind coming right here at 10, right here it's going to be 20, right here it's going to be 0. So, works like that.
You said earlier that was not raining, so just
yeah. This is a building cloud.
Yeah, inflow is not raining.
Correct. Correct. And the good point of that is, if you picture on a quick scale of what's going on in a cloud, when it's building, it's sucking air upwards, and that's how it's getting taller. So it sucks air in, which has moisture, and as the air comes in, cloud builds, more moisture, gets taller. And if this happens enough, and it happens in perfect conditions, you get a supercell, and that's what you're kind of worried about if you're on the water. That's what we'll talk about next. So this is your average thunderstorm. Oh, thank you. Can you guys see this, or should I turn the light off? All right. Thanks. Okay, so this is a cumulonimbus cloud. This is a kind that has lightning and has it gets really tall. So here we go. This is 12 kilometers. Do the conversion yourself. That's really tall, like 35,000 feet, 40,000 feet. So this is an accelerated version of an inflow cloud. It does both. And what we can see in this is, have you guys ever heard the term the calm before the storm?
Yes.
All right. So what's happening in that is you have your warm air getting sucked up, right? Because we can see it in the graph. It's sucking up and it's building the cloud to get even more power. At the same time, there's outflow on the other part of the cloud in the middle. Now, when these two meet perfectly, you get the calm before the storm. That's right about here. Now, the next thing you notice is if you're ever next to a storm, you get this huge blast of wind right before the rain hits. A cloud like this, I'd say, would be 2 or so minutes. And you can kind of, if you're offshore racing, you see this line about half a mile away, and it gets to you in like 30 seconds. So it's like, holy crap, get the kite down now. Like, the shit goes down. Yeah, and this is why you want to keep paying attention to clouds like this. What else? Same thing happens with cumulonimbus, where you can count on the wind coming in and out of the cloud to add and subtract with surface wind. And you use triggers like if you see rain in a really, really tall cloud, expect a squall line. And if I didn't clarify, a squall line can mean you can be out sailing and there's like 10-mile-an-hour winds. You see a cumulonimbus cloud because it's really, really tall and there's not many clouds around it. And right before that rain hits, it's going to blow like 40 or 60. When you hear a severe thunderstorm warning, that's what they're talking about, these clouds. The other cool thing is, well, cool to me because I love tornadoes, but right here on the front edge, I'm going storm chasing. Tornadoes spawn right about here. Now, let's say you're tornado chasing, I mean, that's pretty cool to me. If you're tornado chasing and you're not paying attention to where the clouds are going, you could end up in the rain shaft right here, and the tornado's right on the other side, and the clouds can move unpredictably, and tornadoes can move 40 or 50 inside this range right here. You can be in rain, not see anything, pop out, tornado right there. So that's why whenever you're trying to keep track of a storm, you try and stay on this side, away from the rain wall. And hail also happens right here. The other thing that's like typically the menacing cloud you see is a roll cloud. This is at Bayview over the summer. This is when a section from right here breaks off and goes in front. And it's also, whenever you see a roll cloud, it's a warning sign that there's a way bigger cumulonimbus cloud behind it. So, yeah, cool picture. But this in itself is harmless. Like, there's no lightning, it's not raining. You'll get a blast of wind when it comes closer to you, and then it'll go away. And if you want to guess, the wind in this picture is blowing this way. There's a flag right over here. And you can see, I mean, I can see from here, the wind indicator on top of the club is pointing that way.
Is that Victoria's boat, the Black Bass?
No.
Yes, it is.
Yes, it is.
Yeah, it is.
No, it's too skinny.
No,
That's too skinny.
For sure, let's argue about it.
Yeah. Okay, this is the last slide. So now I'll just show you guys my favorite weather sites. My favorite radar site and data site is Weather Underground. And if you guys heard about the class Extreme Weather, it's taught by the creator. He created the first internet site or website dedicated totally to weather. So if you're ever wondering how long until it's going to rain, or you're wondering if you should get ready for practice, stuff like that, you go to this site. And the cool thing about this is this ad. So it has all these extra things where these are all weather stations linked up, and you can pull up info on each one, but they really clutter up the graph, so I turn it off usually. And then what you do is you go to radar, click this little button, and go to storm tracks. Really?
That's going well, don't worry.
Oh yeah.
Maybe got an ad block, man.
Maybe that'll load. So this website also gives satellite, this is cloud cover. Darker colors mean higher clouds, mean cumulonimbus. Well, these aren't really cumulonimbus because, I should mention that. There's a difference between short clouds where if you ever, let's say here's Michigan. Yeah. Nailed it. So a supercell line of severe thunderstorms that would trigger severe thunderstorm warnings and everything would be about this. It would be really long, and it would have red spots here and here. And this is characteristic of a supercell with cumulonimbus clouds. Now, what we're seeing with this kind of radar tracking is a large mass of rain that's like this big. This isn't dangerous. This is dangerous. This spawns tornadoes. This spawns gale winds, a whole lot. The other cool thing about this one is it lets you overlay severe weather, gives you tornado reports. None right now, but after like any spring day, it's cool to see them. Okay, here's the storm track thing I was talking about. It tracks each individual cell, and it'll tell you characteristics. So this is a rotating thunderstorm. Top is 21,000 feet. It's moving 60 miles an hour. And then if we look at one of these individually, like right here, this is 20-minute increments. So there's an hour. Let's say you're looking at a storm over Lake Michigan and you're wondering if you should get ready for practice. Pull up this site, turn on storm tracks, and you can go like this on your computer screen and say, oh no, it's 3 hours right when we get to the spot. Last thing, wind finder for wind. All this does is plugs and chugs all the data the government hands out. So like I said, you're best off just looking at isobars.
And this is an app. Windfinder is an app on your iPhone too.
Yep. And this is just another model thrown up by Windfinder. Any questions, you guys? Cool. That's it. No quiz.